All right, welcome to the first lesson using this new system. Just to make things a little bit more streamlined, I've combined the two lessons into one. So you'll see in the homework category here that you have today's homework from 9.2 and then tomorrow's homework from 9.4. And remember that your assignment is to upload the presentation problem as a picture, and that's how I can also notice and see how people are working on things, maybe provide feedback if you're stuck, and then it also allows these to appear as assignments on the to-do list that you have. So, if you haven't already, print the notes or get them set up, and let's get started talking about probability. Now, hopefully you did a little bit of review of probability from last night's homework from 9.2. So what I want to talk to you about is some of the notation as well. Here, if you roll 2 die, some books will call these game cubes, find the following: the probability that their sum is above 10, or what says here, p doubles, and this is function notation. Instead of an f, it's a p, and so this is the function of probability. So if you ever see a capital P in this type of context, that's what you're looking at. So just a shorthand way of saying what's the probability of doubles. So here for the first one, let's look at it. It says that the sum is above 10. So I've included this nice little graphic over here. And if their sum is above 10, that means we are looking at not 10, because it has to be greater than 10. So 1, 2, 3 possible outcomes when you roll the 2 die. And so probability states that we're looking at a fraction where we have the desired outcome, desired the things that we actually want, that we're interested in, over the total number of outcomes. So in this case, there's 3 possible outcomes that would fit what we're looking for, these 3. Out of a total, we've got these 6x6 grid, so that's a total of 36. And we don't leave answers like 3 out of 36. We would write it as 1/12. You could write as a decimal or a percentage, certainly, but 12 isn't going to turn into a really nice decimal. If you want to turn it into percent, you could say 8 1/3, 0.083 repeating with just the 3 repeating. Just leave it as a fraction. All right, here we're looking at p doubles, which remember is the probability of doubles. In that context, what that will mean is that we're getting the same thing for both. So if we're looking at this table here, this would be a double because both dies are 1. And it actually is this diagonal here. They're both 2, both 3, both 4, both 5, both 6. So you'll notice we're going to use the same basic fraction, desired over total. So here there's 6 outcomes that we are interested in that are doubles over the total of 36, which we again simplify to 1/6. If you want to write that as a percentage, you can, but again, I'm perfectly happy as a fraction. Looking at another type of probability, you might see something like a spinner. These are nice equally sized pieces. 2, P of yellow. So again, probability of landing on yellow. Yellow, we have 2 out of the total 8. So our fraction would be 2/8. We can simplify to 1/4. Since this does turn so nicely into a percent, 25% is just fine. But again, fractions or percents, I'm happy with either, unless I ask for a very, very specific one. Here, P of yellow and even. So in this case, we are just looking at 1, because if I look at the 2 yellows here, the only even one is this one. Even numbers meaning that they're divisible by 2. So that's 1/8. Can't be simplified, so we just leave it as 1/8. or if you wanted to write it as 12.5%, that would be fine. Looking at this spinner, I want to talk about the two different types of probability that can happen. We can talk about theoretical probability, which is what we've been doing up until now, and we can talk about experimental. So theoretical probability is what we expect to happen. What would the probability be in a perfect world? And that's what we've been doing up till now. So theoretical probability, right, we expect that 25% of the time it would land on yellow on this spinner. However, if we did a test and it only ended up on yellow 20% of the time, we wouldn't necessarily say, oh no, we were super wrong. It's just that the world doesn't always perfectly work out the way that we think it should. So, and that's the difference between theoretical and experimental. Experimental is probability based on the test you did. So while the theoretical probability might be 25%, if we actually did a test, it might be anywhere between 20 and 30 and still be just fine. Again, usually close, but they're very rarely exactly on the same between theoretical and experimental. So for part C, in an experiment with 200 test spins, how many would you expect to land on a prime number? So since it's saying expect, we know that that's a theoretical probability problem. Quick review of then prime numbers. These are numbers that don't have any divisors besides 1 in itself, meaning that they have two factors, they have two divisors. And so here, in this case, between 1 and 8, the prime numbers are 2, 3, not 4, but 5 and 7. What some of you are going to do is try to put 1 in there. 1 does not have two factors, it just has 1. It's not prime. So we have 4 out of the 8 possibilities, right? 1, 2, 3, 4. So then the theoretical probability is 4 out of 8, which would be 1/2. Again, if you want to write 50%, that's fine. Here, in part D, in an experiment with 200 tests, the spinner landed on blue 85 times. What is the experimental probability of landing on blue? So in this case, we're not talking about the 3 out of 8, which would be the theoretical. We're talking about 85 out of 200 because it landed on blue 85 times out of the 200 spins. So 200 is the total because that's the total number of tests. These are both divisible by 5, and so your final fraction is 17 over 40. If you want to write 42.5%, that's fine. And then the theoretical probability, as I said, would be 3/8, which would be 37.5%. So you'll notice that they're similar, but not exactly the same. Please let me know if you have any questions about probability. These are your notes for this week, and I'll be on Zoom, I'll be on Google Classroom, and I'll be available by email.